So here is question PU2 16, again on projectile motion. This one says that a particle is projected with a speed of 32 meters per second at an angle of 40 degrees to the horizontal. You are asked to find the horizontal and vertical component of its velocity after 2 seconds. All right, so let's see how we go about this question. So here is the scenario of this question. We want to find the horizontal and vertical component of the velocity of this particle after 2 seconds. Now, from the previous question, we know that when an object is projected at an angle like that, it is moving in 2 directions at the same time, and the horizontal velocity remains constant because there is no force in the horizontal direction to either speed it up or to slow it down if we assume there is no air resistance. So the horizontal component of the velocity is going to remain the same. So we are saying that ux, I'm going to write here, so ux is always given by u cosine of theta, and it remains the same throughout the flight of the object if there is no air resistance. In our case now we have 40 degrees, so this is going to be u multiplied by cosine of 40 degrees. So therefore the horizontal component is going to be in our case 32 multiplied by cosine of 40, which gives me 24.5. So this is going to be 24.5 meters per second, and that is the horizontal component of the velocity. What about the vertical component of the velocity? Well, the vertical component reduces as the object is going upwards and increases as the object is coming back down. So we can use the formula velocity at any time is the initial velocity plus a times t. So v is u plus at. If we use this formula, final velocity, so if it's on its way up, final velocity vy, or if you like uy, is going to be the initial velocity in the vertical direction, which in our case is going to be u sine of 40. We know our values. The initial velocity u is 32, so we'll say 32 sine of 40 plus ga times t, but our a is acceleration due to gravity. On its way up, that is negative, so we say minus gt, which is 9.8, okay, or 10. I think the question has said to use 10 meters per second squared for the acceleration due to gravity. So if we put 10 there for this, we'll say minus 10, minus because we are going against gravity, multiplied by time, and we are looking for this after 2 seconds, so we multiply by 2 there, okay? So this did not matter. It doesn't matter what time it is. This remains constant irrespective of time. This one depends on time, and so according to this formula. So the final velocity, therefore, or uy, is going to be 32 sine 40 subtract 20. And if I work that out on my calculator, what do I get? 32 times sine of 40, everything minus 20. And that gives me a velocity of, it's a very small velocity, 0.6 meters per second. So the velocity is going to be 0.5. It's 0.569, so 0.57 meters per second 2 seconds later. Okay, so the speed will have reduced appreciably after 2 seconds. Okay, so as the object is moving upwards, the speed is reducing, so eventually the speed is going to be 0. So this is just before the speed actually becomes 0 and the object starts going downwards. This becomes the horizontal velocity. I hope this makes sense. Once again, let me know if you need further explanation, especially how I got here. Remember, this is a final velocity, is initial velocity, but initial velocity in the vertical direction is u sine of theta. So in this case, it's in fact, this is in fact 32 sine of 40. That's the initial velocity at the bottom there, on its way up. As it moves on upwards, that velocity decreases, and it will decrease to 0.57 after 2 seconds, okay? All right, we'll look at the next question.